Hey, if you're here, you're coded with Paris, and in today's lesson, we're going to talk about that third and final leg of logic flow, and that is called loops. Stay tuned. Hey folks, if you're here, you're coded with Paris. I'm Paris, software engineer. We are going to cover the final leg of logic flow, which we are calling loops. Sounds like something that should be in your cereal bowl on Saturday morning, but it's actually something that is really pertinent to developing really good programs. We're going to dive into that 20% that's going to teach you 80% of what you need to know about loops and how to use them. And you're going to add that nut and bolt to your toolbox and become a better programmer. Let's go on a little walk down memory lane. First, we talked about how basic logic flows starting from top to bottom. Then we dove into functions and how logic flows with functions. We talked about how logic flows with branches. And now we're going to talk about the third final leg of this logic flow conversation, which is all about loops. So what the heck are loops? Basically, loops in coding are a way to force your code to repeat a behavior for a certain amount of time. Usually it's a given amount of time. That given amount might be determined a couple of different ways, which we'll talk about later. But to understand loops, I'm going to attempt to give you a little bit of an analogy to kind of step into the topic. So remember Groundhog Day? I don't, because I've never seen the movie, but because it's such a legendary movie, it's quoted all the time, talked about all the time. I know the premise. Spoiler alert. Let's talk about it a little bit. So the plot of Groundhog Day is that the main character, played by the legendary Bill Murray, somehow falls into this pattern of reliving the same day over and over again. He falls into a time loop. At first, it was a lot of the same boring or sad stuff happening every day. But because the main character remembers what happened in the previous iteration and the previous days, he eventually gains a different perspective and uses that knowledge to change things, eventually for the better. At some point, the time loop stops, and so the main character is able to step outside of that loop and live a normal rest of his life using that knowledge he gained from doing that time looping. Man, that seriously sounds like a really good movie. I might watch it soon, but let's keep that in mind as we start to dive into our example of loops, and we'll sweep back to how things are related, okay? So let's talk about loops a little bit. There are mostly two different types of loops that you'll see in almost every coding paradigm out there. There might be more in some cases, but I can think of two that I've seen in my entire career. And we'll dive into examples of both. But the first one that we're going to talk about is the for loop. What's a for loop? Usually a for loop refers to a loop that has a predetermined number of times to be ran, meaning you only use a for loop when you know exactly how many times you need some behavior to be repeated. Most languages have a flavor of a for loop, and actually in most languages, the syntax of that for loop look the same. I'll show you JavaScript's version in this tutorial, of course, but you'll probably recognize it when you see it anywhere. So let's look at the example structure of a for loop. All right, and so in our Coding with Paris folder, let's go ahead and highlight the entire project or click outside so this box is blue. We'll create a new folder and we'll call that lesson 5. Okay, and then with that folder highlighted, let's go ahead and create a new JavaScript file called loops.js. And also, let's open up a terminal here. You'll see I have one open. You can do that by going up to terminal, new terminal, and it'll open up a terminal window for you, or pressing your hotkeys, whatever those might be. Let's talk about for loops. We'll start with a simple example. So the way you see a for loop in JavaScript is the following. You have the keyword for, you have an open and close parentheses, and inside of the parentheses you have 3 different things going on. So the first thing is you're setting a variable, and you can give that variable whatever you like. Most times you'll see that people just use a single character as the variable. It's fine, since most of the time this is kind of a throwaway. So that's the first thing. The second thing you'll see here is that variable again, but you'll see that that variable is doing some type of comparison to something else. We'll talk about what that is in a second. We'll go ahead and end that with a semicolon as well, just like the first piece. And finally, you'll see that variable with some type of plus or minus characters in there. Typically, you'll see plus. And then outside of the parentheses, usually you'll see a curly bracket and you'll see some code inside of those curly brackets. So in our case, we're going to do something like console.log. Think I can. So what's going on here with this for loop? Well, this for keyword is a reserved keyword, meaning usually telling the computer that you want to start repeating some behavior. So it's kind of an activation for that for loop. And remember, keywords are words you cannot use in any other parts of your code alone. So I can't have anything with for. I can't have a variable name for example. Okay. Of course, you got the parentheses, what we talked about here. And inside, there are 3 expressions that we shared. Okay. So let's talk about those expressions. The first expression is basically setting up a variable that we're going to call our iterator. And basically what this is saying, okay, we're going to start doing some counting, because remember the for loop is used for times that we know exactly how many times we need to repeat some behavior. And we're going to count how many times we do that behavior, but we're going to start at 0. And then the next piece here is saying we want to count as long as this variable that we set called I is less than the number 10. And then we have a semicolon here kind of separating that. And then finally what we do is we say we want this I after every time incrementing the count, we do it by 1. I can also do I plus 1, which means the same thing, but this is kind of a shortcut way of saying just add 1 to I. Okay. So in this example, we're saying we want this behavior inside of this parentheses, when the code is here, we want this behavior to happen. If we're starting at 0 as the count here, we want this to happen 10 times, or basically as long as this I here is less than the number 10. At the point that it's number 10, then what happens here is that the count stops. Now, this weird behavior when you see things starting at 0 in loops, this is actually something you'll see all over the place, because in coding, you don't necessarily have to start with 1. Okay, so it's a pattern you'll see all the time. But anyway, I know it's a little tricky, but you'll see this pattern all the time. You kind of get used to seeing it. So what happens here with this for loop if we go ahead and run it? Okay, let's go ahead and do that. So in our coding with pairs folder, down in the terminal here, let's go into the lesson 5 folder, and then inside of lesson 5, you'll see we have if we list what's in that folder, loops.js. So go ahead and tell Node to run loops.js here. And what do you get? You get the program actually repeating some behavior, actually saying, I think I can, 10 times if we counted that out. So this is a simple example of a loop, and you'll see that all the time. So I'm going to go ahead and comment this out. And let's dive into a second example and change things up a little bit. In this example, we're going to count backwards with a variable for the iterator. Okay, so just to show that we can do this. Okay, so let's set a variable called bottles of beer and set it equal to 10, and then we're going to do another for loop. So for, again, open curly parentheses, you don't have to put a space in between the two. Let's set our variable I again, and we'll set it equal to bottles of beer. So now you'll see here that we're setting this variable equal to the bottles of beer. So that would be 10 if we were to fill that variable in. So that's the first expression. Now let's set the second expression when we're saying we want this to repeat until I is greater than 0. And so basically once we get to 0, we know we're out of bottles of beer. And then we're going to say, instead of I plus plus, what we've seen in the last one, we're going to say I minus minus. And do not forget to add your semicolons. And do not make the mistake of putting a semicolon here, because that's not the correct format. Inside of the open and curly braces, what we're going to do here is type console.log, and then we're going to use our special quotes here, which you get by doing kind of the tilde quotes. I don't know what you call these, but They're special because you can do some cool formatting in JavaScript. Okay, and I'm going to make some space here. And the first thing we're going to do is just hit tab, do a $ here, and say we want bottles of, let's spell bottles, right? Of beer on the wall. And in our code editor, we can express some special codes to actually copy a line down. In the Mac, it is Command Control down. I'm sure in Windows it's something else, but anyway, just keep that in mind. It's a cool slick trick if you don't want to retype things. For singing the song here, I can say take one down, and pass it around. Now there are I-1 bottles of beer on the wall. Yeah. I don't know about you guys, but I like making code that sings songs for some reason. So a little bit more information about what we're doing here. So in console.log, we obviously have the ability to put in an expression. And this is actually kind of in a variable, but it's kind of an expression. There's this code that's being ran here is going to add our strings, but also it's going to fill in everything that has this representation here with a variable that exists in the code. In this case, I is the variable, and so it's just placing I in here. So these are expressions inside of expressions that are getting fulfilled as things are being written. So if we were to come down to our console and clear it out, and then press up twice and hit enter on loops.js, this should run. All right, here we go. So I'm going to scroll up just a little bit. Actually, let's make this window a little bit larger to let you see what's going on here. This program, this simple piece of code that we wrote here, now sings the bottles of beer on the wall song. I'm sure there's an actual name. Starts with 10, right? 10 bottles of beer on the wall, 10 bottles of beer, take one down, pass it around. Now there are 9 bottles of beer on the wall, and it just repeats all the way down. Boom, 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 boom. But notice we don't actually get a 0 count. That's on purpose because, again, with that 0, you have to just practice thinking about what that 0 means. 0 is the limit, but it's not inclusive. Or if you start at 0, then you're not counting the fence post on the other side, right? So anyway, just keep that in mind. Also, you'll see that the cool thing about these loops are that we're able to quickly get our program to keep running this behavior, maybe slightly changing things a little bit as it moves on. Again, for loops are cool when you know exactly how many times you need to run something. Let's give an illustration of what's going on here with these for loops quick to tie it up. So if you recall, this is an illustration of how the logic typically flows, which is from top to bottom. The difference here with loops is that the logic here stops at the beginning of the loop and then begins to repeat some behavior until a condition is met. And usually that condition involves the expression given inside of the for loop's parentheses. Once that expression is met, then the logic jumps out of the loop and continues to flow downward. So before we continue with the content, I wanted to ask you to like the videos, subscribe to the channel, and share this content with anyone that you think might benefit from learning how to code, which is probably everybody. A lot of time and effort goes into building and editing these videos. It sure would make me feel good to have some sign that I'm making a difference or giving some value to you all. Of course, if you have any questions or comments, go ahead and leave them down below, and I'll try to get back to you as soon as possible. Hit that bell notification if you want to be notified every time I post a video. Thanks for your time. Let's dive back in. Let's go ahead and talk about our second most popular form of loop that you'll see in coding. So we'll comment out this, and we'll talk about the while loop. So the while loop is a type of loop. It has similar behavior of a for loop, but it's actually used to perform instructions until a certain condition is met, or while a certain condition is not met. And usually you use these loops when you don't have an exact number of times in mind of how many times you want the behavior to run, but you want to use some condition to kind of determine what that is. There are two flavors of while loops. While loops are probably the most popular. So let's look at an example of a while loop and break that down first. So what we'll do here is kind of set up an example to help us understand things a little bit more. So let's create a variable called let confidence meter equals 0. Let's do another one. Let max confidence equals 10. And then we'll work on our while loop. We type the keyword while, open and close parentheses, meter less than or equal to max confidence. This is our expression here. We're going to do an open and curly braces, and inside this open and curly braces, just copy the text that I'm going to write down. If confidence meter equals max confidence, let's do a triple equals on that. Then we'll tell the computer to say, I know I can. We're going to add to this if statement, this branch here, because we want to tie some more logic. So in the case that the confidence meter is not 10, then we definitely want to do this. Make the computer say, I think I can. But at the end here, what we want the confidence meter variable to be incremented by 1, meaning you want 1 added to it, okay? What we'll do here is we'll save that. We'll come down to our terminal, we'll clear it, and then we'll tell our program to run this code here. See, what's happening is that this while loop is running as long as the confidence meter is not at 10. The code will say, I think I can. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So on the 10th time, it's going to jump in and it's going to say, hey, now this number is going to be equal to the max confidence, the most confidence we have. So we go from I think I can to I know I can. Then that condition is met. From an illustration purpose, the logic here behaves the same as a for loop, and so we don't really need to look at a separate picture. Again, what's happening is that this code here is going to keep circling until the condition is met. Then the code moves on and finishes its execution. A couple of things about the while loop I want you to make sure to note, okay? If you have code and you're running the while loop, what the while loop does is it checks the condition before anything is written. Okay, so in the case that you want this code to start the loop until a certain condition is met, you do this. So it may not run at all if the condition is already met. A gotcha with while loops is that you have to always make sure that the last time you want to iterate is accounted for. But I want to show you something else here about while loops that will be very important. So let's go ahead and comment that out quick and talk about something called infinite loops. So with while loops, you always have the potential to accidentally get your code to sit and cycle forever. So let's give an example of this and then we'll talk about it a little bit more. What we're going to do is we're going to uncomment this code here and we're going to copy this function here down below. Uncommented, but the difference here is I'm going to comment out this confidence meter incrementer. And so what do you guys think is going to happen here if we decide to run this code, this version of this while loop? Let's go ahead and give it a shot. We'll clear our console, press up a couple of times and hit loop.js. And as you can see, this code is just repeating, going on infinitely. And the reason being is because this confidence meter never increments. And so we're just unsure forever. And we've created a condition called an infinite loop. So a couple of things to note about infinite loops as you're seeing this happening here. Infinite loops can be very dangerous in code, okay? Very dangerous. You don't want anything like an infinite loop to happen in things like cars or planes or anywhere you might have code, because it's basically freezing your code. It will never, as you're seeing here when things are just kind of cycling, it will never ever leave this loop. Now I have to do something special to end this infinite loop, and I wanted to show you this. Sometimes you can hit Control-C and your computer will respond and stop looping. Probably can hear that my computer is its fan starting to kick on, because what happened here with the infinite loop is it kicked up a lot of memory usage. It kicked up a lot of the load on my computer here, because it was just running the same thing over and over and over and over again. Another reason why it's dangerous to create infinite loops. So I'm going to repeat this one more time, but make sure that whatever condition you meet here, you're not only considering your last condition, your last iteration, but you're also making sure that while using while loops, that you are altering your code inside of here to eventually get this while loop to exit when the condition is met. Otherwise, you create an infinite loop, okay? So just wanted to share this with you. Infinite loops are bad. They're naughty. Okay, so the second type of while loop you might see is something called a do while. And I'll be honest, I've rarely seen do while loops. Usually because you can kind of do whatever you need to do with a while loop, but there is a special, they don't exist for nothing. There's a special reason why you would use a do while loop. And I'll set up the structure. We'll talk about the structure and why. Okay, so let's do kind of what we did before. Copy the variables up above for confidence meter. I'm going to go ahead and comment these out as well. Once I copy them, so we're going to create new copies of them down here. This time, we're going to create a do while. And actually, real quick, let's alter this to say 10. And I'll just do this for our notes here. I'm going to say notice confidence is on 10, right? All right, that's going to be important later. Now let's set up our do while loop. So now we have to do the keyword do in JavaScript. This is how you do it in JavaScript. And what you do is you have some code that you want to execute in here. And let's go ahead and write out that code. Let's say if confidence meter, oh, there we go, thank you, equals max confidence. I don't have to type anything, okay? We're going to check for that condition. We're going to say console.log. I know I can. Else, obviously, console.log. I think I can. So very almost the same example as what's above here. But then, of course, we want this to run no matter what, confidence meter plus plus, because if we don't do that, then things are going to happen. But the difference here is that the do while loop has the do where the code is there, and then you create a while, and then you place the condition in that while. So again, we're going to do confidence meter while confidence meter is less than or equal to max confidence. Okay. So we're going to run this here. We're going to run this first. So clear our console, and then we'll run the code here. And you'll see here that it ran once and then exited. Isn't that interesting? So let's talk about what's going on here, okay? Our confidence meter started at 10, which in the other actually would have meant that this didn't run. But you'll see here, even though these are both 10, the code did say right away, because it knew it had top max confidence to begin with, it said, I know I can, and then exited. Why is that? Well, with the do while loop, the logic is that the do is ran first this time, and then the condition is checked. And if the condition is checked, then we don't do another iteration of what's going on here. Instead, we're done. So why would you use a do loop over a while loop? Well, you would use a do loop if you want the code that's inside of the loop to at least run once. Okay, and there are some good reasons of why you might want the code to run at least once. I can't think of any at the top, but just think about it that way. Otherwise, you would use the regular while. With the while loop here, just remember you don't need to do the brackets because the do is handling that bracket. So just slightly different. Also remember again, you can also run into the trap of infinite loops. So make sure again that the code that you're running in that loop, the code that you want to be repeated, doing what it needs to do. And I can just demonstrate. So if I took this back down to 0 really quick, just for giggles, and press that, then we get the same condition. It'll run think I can, 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 up until the 10th time. And then it'll say I know I can. But we'll keep that here for our note's sake. Why even use while loops? Well, like I said, if you don't know how many times that you need the piece of code to run, you use the regular while loop if you want something to start looping, if a condition is set up and to take place until that condition is met and you know it's going to be met. Or you use the do while if you want something to happen once, check the condition to see if something happens, and if it didn't happen, to continue doing it until it happens. Does that make sense? Loops are commonly used for coding paradigms when things start to become a little more complex, especially if you want code to run continuously, to continuously check things. Think of things like video games, right? Video games are things that are running on continuous loops, right? They're paying attention to what buttons you're pressing, where you are in the stage. There are loops just constantly going and checking things and changing things around you, kind of like what we do in our if conditions, right? Changing things around you as you're moving through these virtual worlds. The same within your car. If you're inside of a Tesla, it has a radar that's scanning around you, and it is doing a continuous scan, which is probably some type of while loop, right? While you're driving, while you're in the condition of driving, check around you. And if you see anything that looks like it might be too close to you for you to respond or move out of the way, then it will hit the emergency brakes and stop. So that's the cool thing about while loops, and they're a good nut and bolt to have in your belt. So let's bring it back to our analogy on Groundhog's Day and talk about how loops even relate. So let's think of loops in Groundhog Day as the time loops that the main character has to continuously repeat. And the things that character does each day are the pieces of logic that are to be performed within the loops. The perspective that the main character gains as he continues to loop basically changes the condition of his life on every iteration and changes his condition for the better. And then finally, the condition actually changes things enough where the time loop stops are kind of like the conditions that you see in the parentheses at the beginning of the for loop or the while loop or the do while loop. So finally, where the man goes on to live an awesome rest of his life due to what he's learned in that iteration, that is more relatable to where that logic exiting that loop and continuing to run the way it typically runs from top to bottom. Now with the logic and perspective that it has from that looping. So something to note here is that most languages have similar format to the while loops and for loops. It might change super slightly, but they're pretty much straightforward and you'll recognize them as soon as you see them. So to tie things up here, we're going to go into a coding example. So let's prep our code to do that right now. In our lesson 5 folder, let's click the folder again and click add a file. And we're going to add a file called loopsexample.js. Don't forget to add that extension, or your computer won't know what to do with that file. And what we're gonna do here is set up the requirements up top and then start writing our code. So first requirement here is that we're supposed to loop through a list of states, and we're gonna have a list of given states here, and we'll talk about how we get those lists of states. And then we're gonna count the number of letters in each state's name. And we're going to do this using a combination of a while loop, and we'll say the while loop to go through states, and a for loop to count state name length. Okay. And then finally what we're going to do is print the state next to its number like this. Okay, we're going to have state name, and that number here is just going to be the count of letters in the name. Okay, pretty simple. Okay, so of course what we're going to start with in every one of our programs here is a function here that we call run. This is going to be our main function, the main function that orchestrates all the different behaviors in the program. kind of get used to doing this pattern because you'll see this pattern all around. Maybe it's called main in some languages, but the whole idea here is you have the orchestrator kind of doing what it needs to do. Because it's the orchestrator, we're going to also call that function here. So when we call our code, it will run what's in here. Okay. The first thing we're going to do is go ahead and get a list of states to kind of work with. We're not going to hand crank all of those states. What we're going to do is create an array called state list, open and curly brackets, and then we're going to follow a link that I am going to put in the description below, a list of states. I'm going to show you something cool you can do. Okay, so just follow me for a second and Google list of states. And you'll see here that this purple link is the one that I visited before. You'll find here a list of states, and we want actually the ones that are surrounded by quotes, because that is the condition of which you can put strings inside of an array, which is what we're going to work on. Okay, so we're going to grab this one. You can grab either the single quote or the double quote here and paste it inside of your array. If you have a code editor, it might tell you right away, hey, something's wrong here. We got some squigglies. Well, if you're pasting this in from the website we have, one of the things you might notice is that the quotes, even though they look like double quotes, they're actually not the quotes that we're used to seeing. They're a special type of funny looking quote. So let's change these to quotes that we need. So we'll go to edit and we'll go to replace. First of all, highlight the double quotes, go to edit and then go to replace, and you'll see that this special quote is here. And what we want to do is we want to place any quote that looks like that with just a straight up and down quote here. I hope you can see that. And what we'll do is we'll press, and there's probably a replace all button here, but I'm just gonna hold it until it says no more results for that. And we'll do the same thing for the second quote here. I'll just actually copy it, paste it up top now, and then we'll replace it with those single quotes again. And we'll keep going until we are out of instances of that as well. And now, as you can see, we have a list of states, comma separated, that will help us with the rest of this code here. So let's just take a quick break and then go back to the browser here and kind of talk about this. So, and the cool thing about the internet is that you can probably find some pretty cool lists and things out there just by Googling. As you probably saw from my Google history, I actually found some cool things like a comma delimited list of Pokemon. So if I wanted to do some cool thing for my son here who's really into Pokemon, I could probably find a comma delimited list of Pokemon and do some cool statistics and things up there. So cool thing about the internet is that some folks have taken the time to do some fun stuff for you already, or helpful stuff. Always check to see what's out there for this sort of thing, and also for someone who may have a coding example for you. All right, so anyway, I'll have a link to that below. Let's get back to our code here. So I'll make that full screen, why don't we? All right, so jumping back to our code here, right, we have our state list ready to go, and then we have our run function. And remember, what we want this code to do is to loop through these states using the while, right? So I could have copied this, I guess, loop through the given states using the while. And what I wanted to try to do here is, since we have a list of states and I'm using the while loop, what I'll do is I'll just pop a state off, do my work with it, and throw it away for each one. This is how you do that using an array. First thing you do is you obviously write your while, and you'll say while state list.length is greater than 0. That's our condition here, and we'll do some work. This dot length here is a way for us to actually, it's a way for the code. I'm just going to say dot length is the way to know the size of an array. So the count of items in an array. Keep that handy. We'll talk about arrays extensively later on, but this is a cool thing for you to know. So in this case, we have a count, and we know how many times we're gonna, or at least the condition of which we want to stop looping is while we still have states that are in that array, because we're gonna take one off per iteration, throw it in the garbage once we're done. Okay, let's process. Let state equals state list dot shift. Okay, what is this? So what this is doing is this is giving us state in question. Maybe I should say, we can say given state. And what we're saying is give us the state that we want to work with and set it as this variable here from the state list. That shift function is another array function that grabs the first item on an array. Keep that in your pocket as well. And we'll circle back to it later. Grabs first item in array, and it's first from left, right? And what it's going to do here is grab that first item and assign it to this variable. The next thing we need to do is for a state, we need to count all the letters in that state for us, in order to get the total count, right? So the way I would do that, since this is a different requirement, is I would actually create a separate function. Let's do this first. Total letters equal, and then we'll create a separate function to count the letters in the state. And so we'll call that maybe count letters in state. And why don't we make that function so we just pass in the state as a value, and we'll set whatever comes out of that equal the total letters here. We'll jump up here and create a function called count letters in state, and your IDE will help you with that. And we'll again let the state, given state here, be the parameter, and then inside of here we're gonna return a count. So the way I typically do this type of behavior is you'll see that I'll create a variable, let count equals 0. And the reason why I'm setting it equal to 0 is because I want to add to it, add to this count, and then at the end what I'm going to do is return this count. Inside of here what I'm going to do is create the for loop. So for I equals 0, I until I is less than state dot length I plus plus, because I'm going to increment here. So what I'm saying here is that if I set I equals 0 until I is less than the length of the state, we're going to increment counting, and then we'll know when we're done here. But until we're done, we're going to add 1 to our count here, and when we're done we'll go ahead and exit out. Now, little thing that you might have noticed here is that state is a string. State, as we're receiving it here, let's say given state, sorry about that. Given state, as we're receiving it here, is actually a string. And with a string, you actually have a property dot length as well, and that's just how many letters are actually in the string. So that's the cool thing here, is that we could actually probably use that as a result. We can say return string dot length, but that's cheating. Let's go ahead and add a count, add it here, and we'll return, and then we have our given letters here. Finally, our last requirement here is to print the state next to its number. And so what we could do in our main function here is go below that total numbers count here, which we captured. So now we have a state and the numbers. We go down here and we tell the computer to say that state, and according to the requirements, total letters is what we want there. And we'll end that with a semicolon. Now that wraps all of our requirements. Let's go ahead and clear our terminal and run this code and see what happens. I know what the problem is. The problem is actually running the wrong code. So let's tell Node to run loops example.js. And you'll see we have a problem here, and that problem is given state is actually the name of that variable. So let's clear things up and do it again. Still missing something. Oh, given state. Oh goodness. Okay, good thing we have our editor that lets us know what's going on here. All right, let's see. Third time's the charm. Save our work, come down, clear the terminal, and run again. And you'll see what happens in almost an instant. for all of the states, we start counting. We have this line printed with the count of the states, and everything runs through, gives you the count of the numbers in the state, and then it exits perfectly, not a continuous loop. It exits. And folks, this is a very simple example, but an example indeed of how you use for loops and how you use while loops. So let's go ahead and talk about what we covered in this tutorial really quickly to bring things full circle. So we talked about loops, what I'm calling the final leg of logic flow, which essentially is a way in code to tell your computer to continuously repeat on a piece of functionality or behavior until a condition is met. We then went on to talk about how there are two different types of loops. There's a for loop and a while loop. The for loop is a loop that you run when you know how many times you want a piece of logic to run. The while loop is a loop that you use in a condition that you don't have an exact number, but you instead want to depend on a condition or something that is to be met, either the state of the computer or the state of the code. So you're no longer counting with a while loop per se, not necessarily, but you are instead performing until some condition is met. So in both for loops and while loops, they're very common and they both depend on a condition or a set of conditions. For loop has 3 different parts in it in its condition, and we talked about all of those as well. The first one is setting up basically when you want the loop to stop running, and the third one is just the iterator. There are 2 types of while loops. There's a regular while loop and a do while loop. The regular while loop is a loop that you use when you want the condition to be hit first, and you want the loop to run until the condition is met, where the do while loop is used when you want that code to at least be ran once, and then if a condition is not met, to continuously run until the condition is met. So there's a slight difference between the two. Use them, however, make sure you don't fall into the trap of infinite looping. Again, this is a very dangerous thing depending on what you're doing here. It can definitely bog down your computer and anything else, because basically it's just going to keep your computer continuously looping and never let that logic continue. Now, we did throw some illustrations in to show how the logic is working with loops, and it's pretty straightforward. And then we wrapped up everything that we talked about here as far as loops go by digging into an example of a program that uses both the for loops and the while loops to do something interesting, which is parse some states and count the number of letters in the states, and then give you a nice printed count at the end. So folks, that is all for this concept that we are going to call loop. This is the 20% that'll teach you 80% of what you need to know about loops. And for our next lesson here, we'll dive in and grab another nut and bolt. Thank you for staying here. You learned lots, and I'll see you in the next video.